Hello everyone, in this video we are going to learn how to check whether a given number is a palindrome number or not. So what's a palindrome number? A number which reads the same as its reverse is called a palindrome number. For example, consider the number 121 and its reverse is still 121, which are same, and that's this palindrome number. Consider an example 123, its reverse is 321, which are not same, and hence 123 is not a palindrome number. Consider a single digit number, say suppose 6, its reverse is 6, which are equal, hence it's a palindrome number. So how we can find it? We can find it by using two ways. First one is full traversal and second one is half traversal. Now in full traversal, what we do is that we find the reverse of the given number n and then we compare both n and its reverse. If both are equal, then we say it's a palindrome number, and if they are not equal, then we say it's not a palindrome number. But we can do the same thing by only the half traversal of the given number n. So what we do in half traversal is that we use some of our observations and we find that for while finding the reverse of any given number n, at a certain point of time, the reverse will become greater than n. But this applies only when our operations are performed on n. What I mean to say is that while finding the reverse of n equal to 121, so if we find the reverse, in each step it will be 1, then it will be struck out. In second step it will be 2, it will be struck out. So at this point we see that this reverse is greater than our n, and following that we make two more observations, that when this thing becomes true, we see that in case of odd palindromes, means those numbers or those palindromes which have odd number of digits follows this thing. It will be always hold true for the odd palindromes that its reverse after this things comes out to be true, that reverse modulo 10 is will be equal to the number. And for even palindromes, it is those palindromes which have even number of digits. After this thing comes out to be true, then we get this reverse will be equal to our number. And hence for the numbers which are either odd palindrome or even palindrome, after these things comes out to be true, either one of the situations will hold true, and hence we will be able to know whether a number is a palindrome or not. Let's just consider an example. First we will consider example of an odd palindrome. Let us consider the same example as 121. So while finding its reverse, what we have to do is that reverse, when we have to find its reverse step by step, so it will be 1, this will be struck out, then we have this 2, and this will be struck out. So at this point this reverse is greater than n, we can say this n becomes smaller than reverse, and we can come out of the loop and we can simply check whether reverse modulo 10 is equal to n or not. Here we can easily say that the 12 modulo 10 is equals to 1. Here n becomes 1 and our reverse is 12, which is 1 is equals to 1, which is true. Hence 1 to 1 is a palindrome number. Whereas if we consider another example of an odd number which is not a palindrome, we can easily see that if we find out its reverse, then it will be 3, it will be struck out, and we have 2, it will be struck out. So at this point our n becomes smaller than reverse and we come out of the loop. Now when we check reverse modulo 10 is equals to our n or not, so we check 32 modulo 10 is equals to 1, is it true or false? So we have this 3 is equals to 1, but it is not true, hence that 1 2 3 is not a palindrome number. Similarly, if we consider another example for even palindromes, we can see that consider an even palindrome n as 1111. We know it's a palindrome, so our observations must hold true. So if we find out its reverse, then it will be 1, it will be struck out, 1 it will be struck out. Now at this point we find that our n is smaller than reverse, and hence we come out of the loop and we check the condition whether this reverse is equals to n. We find that the reverse is 11 is equals to whether it is equals to n, which is now currently 11. Yes, it's true, and hence this 111, it's a palindrome. Now if we consider an even number, I mean even digit number, which is not a palindrome, for example this number 1, 2, 3 and 4, clearly it's not a palindrome, but it has even number of digits. So if we find out its reverse, then 1, 2, 3, 4, and reverse will be 4, 4 will be struck out, then we have this 3, 3 will be struck out. At this point we see that our n becomes smaller than our reverse, so we come out of the loop and we just simply check whether reverse is equals to our number or not. So we find out that the 43 is equals to 12. No, it's not. Hence we can say that our given number is not a palindrome. It's not a palindrome. So we can altogether write it as after completion of the execution of the loop, we can simply check if reverse modulo 10 is equals to n, or if the reverse is equals to n, then we will simply we will do return true. If either of the conditions holds false, then it's neither an odd palindrome neither an even palindrome, and hence we will return simply false. But we have to make sure that we check for the edge cases explicitly. Here the edge cases will be the numbers ending with 0. The numbers ending with 0 can only be palindrome when the number itself is a 0. So any number which ends with 0 can not be a palindrome. So before starting of the loop, we have to first explicitly check if a number has an ending 0, then and the number is not 0, then it's not a palindrome. So that's all for today's video. Thank you.